Okay, so measures of perfect timing, central tendency. Okay, there are two major formulas they've been given, and they're written really differently than how we're used to seeing them. They both deal with mean, which is an average. Okay? Um, this is just a normal average or a normal mean, and this is considered a weighted mean. Okay, even though we use the same symbol. Let's talk about what these symbols mean. This means the mean. Should have used a different word, but that's what this is defined as, the mean. This funny looking, almost like an E, means the sum of. So when they say the sum of, they mean they want you to add up every single value. That's what a sum is. N means the last term. So we don't know how many terms are. So say I'm finding the average of 15 grades altogether. My N would be the 15th grade. So we're finding the sum of all 15 terms, okay, starting at I being the first term. So I being 1, I being 1 to start. So what this is saying is we take the sum, so the very first piece of data, and I being 1, so x at 1, and then we add it to our next one, which would be x at 2, x at 3, all the way up to x at, and we said n was 15, x at 15. It's just, instead of writing all of those out, they've used these symbols to convey that idea. It really just means adding them all up together. N being the number of terms. We said there were 15 terms, so we would divide it by 15. So really, add everything together, divide by the number of terms. We're looking at average. They've just written it really differently. Does that make sense, those symbols, kind of? Okay, so let's try to apply it to this then. This being mean again. Let's say there's 15 terms. So n being the last term would be the 15th term. I being the first term, we start at 1. We need the sum of all of the terms from the first one to the last one being 15. Now because it's weighted, it's a little different. We take the data or the value of the first one, and because they're beside each other, this means multiplication. We multiply it by the weight, or the first weighting of that data. Okay, so all this means is multiplication between the two. Now the bottom part of this says that we don't just divide by the number of terms. We actually divide by all of the weights together. So we take the very first weight up to whatever the last weight is, and if there were 15 weights in it, and there might not be. There's not always the same amount of data as there are weights. Okay, so maybe that's a bad example. Let's say there were 4 weights. We would take all of the weights, starting at the first one up to the 4th one, and add them all together. Okay. When we're working with percentages, which we're about to do, usually the weighting ends up being out of 100. But this question is actually really funny because they haven't given us a value for their final exam. So we're going to compare the two types of means. These are the weightings. In knowledge, this person's getting 78%, but your knowledge is weighted at 25% of your grade. Your application is weighted at 15% of the grade, and they're getting 75 there. Problem solving is 20, they're getting 80 there. And communication is 10, they're getting 85. Let's deal with the first one. Let's find out what their normal average would be in this case. So our x bar is equal to the sum of all the numbers. Well, there's 1, 2, 3, 4. So n in this case is 4. I still starting at 1. And the sum of x at I. Okay, so we're taking all of those terms and we're dividing it by n being 4. So we have to sum all those values together and divide by 4. So I don't know if you either have a calculator, just double check, because sometimes I take things wrong in this calculator. So let's take them together. 78 plus 75 plus 80 plus 85. 318. So we have 318 on top. That's what that is. Divided by 4. This person's average without weights is 79.5. That's not a bad average at all. So this is if we haven't weighted anything. But the problem is we are going to weight things. Okay? So because we're going to weight things, I'll do it in blue, we're going to use weighted average. Okay? Which still states our n I being our first term and xi times w standing for weight. All divided by the sum of all the weights. Sum of all the weights, so n, I, 1, w, I. Okay, so what the heck does this mean? Well, let me get it all on the same page here. This weighting is for this specific mark. Okay. So this specific mark stands for our first one, which would be our xi. It needs to be multiplied by this weighting of 25%. So I can either write this as 78 or I can write it as 0.78. It doesn't really matter as long as I'm consistent all the way through this. Okay, so I'm going to write these as actual values, so 78. I'm not going to include the percentages. But I am going to leave these as percentages. And what I mean by that is I'm going to use them as decimals. Okay? It doesn't matter. We can use both as decimals or the way we're doing it. You'll still end up with the same answer. So what this means is x bar. So our very first case, I'll try to color code everything. 78 multiplied by our weighting, which is 0.25. Does that make sense? Now, this means the sum of. So we did this all in the calculator. I didn't actually type it all out. But the next thing we need to add this to. Okay, so we're going to add this. Our next value being 75 times our weighting of 15, which is 0.15. Okay. And then we add it to the next value of 80 multiplied by 0.2. Does that make sense how I'm converting these? Yeah. And then finally, our last term of 85. I'm going to need a little more room, so I'll move this over. 85 multiplied by 10, which is 0.1. Okay, so that's the top part. That's what these symbols technically mean. Instead of writing it out the long way, they represent it with this symbol. Now the bottom half of this is a little different. It's the sum of the weights. Well, these are all of the weights. Okay, so that means we're summing all of these values in red together. So let's sum them up. 0.25 plus 0.15 plus 0.2 plus 0.1. Okay, that's the sum of the weights. We actually don't include these values here. Okay? These values aren't included for our final weight. So we're going to have to put this all together. So we need a calculator, and this is the tedious part. Let's try to work it all out. Your calculators might be a little better at this than mine. So we're going to try to do this all in one step here instead of going one at a time. So I take 78 times 0.25 is equal to plus, and I got to put this in brackets now, 75 times 0.15 and bracket is equal to, okay, plus, you might be able to type it in much nicer in your calculator, but I have to go through it this way in mine. 80 times 0.2 and bracket equals plus bracket 85 times 0.1 and bracket equals. So I think the number on top is 55.25. Is that what you got? Okay, good. Mine's a bit older than this one. So 55.25. And on the bottom, we could probably actually do this ourselves. 25 and 15 is going to give us 40. So 0.4 plus 2 is 0.6 plus 1 is 0.7. So we have a 0.7. Is that right? So when we divide it by this, 55.25 divided by 0.7 is equal to 78.9. Well, in this case, I was hoping for a better example, but in this case here, the weighted average was almost the same as the average itself. I was hoping to have a bit of a bigger discrepancy because it can be common to have a much bigger discrepancy. But it turns out that this, if we'd done the normal average, it would have been a little higher, right? In fact, if they decided to round, this would have rounded to 80, this would have rounded to 79. So they have a lower average when it's weighted than they did if they just used the normal mean. And in the question, okay, now technically in this question, the second part they said, what does the person need to get on their final to receive an 82%, okay? What I'm going to do is I'm actually going to work from this point here, because what this is all this data has already been collected, okay? All this data has been collected. And this is what it got in the end. They want to end up in this question with a 82, they said. So in order to equal 82, I'm going to use these numbers here. We know that this already added up to 55.25 over 0.7. We haven't included the final grade. Well, the final grade would do, first of all, it would be a whole nother number on the bottom here. We'd have to add 0.3, which makes sense because if it's percentages, it really needs to be out of 1. So we're going to take this 0.7 and we're going to add 0.03 to it. Okay, so it's going to be out of 1. And we also have to add the final grade. So this is the final weighting that we added to it. Okay. Now, I could have done this all the way back here and rewrote everything, but I'm trying to do a little shortcut for us. Okay. So I added the final grade, or final weighting here, and we will need to put in our final grade. Now, this is the tough part. Our final grade, we don't know. So we're going to call it, we've used X before, so I'm going to call it Y. The final grade, or actually F would be nice for our final. So it's our F times the weighting, and the weighting being 0.3. Okay. So let's kind of collect our like terms. Now, does this make sense what I've done? I've added the final grade, which we don't know, times the weighting to what we had before, and I added the final weighting on the bottom. Are we okay with that? Okay. Yeah. Really, this becomes algebra now. We have to isolate for F. So I'm going to collect my like terms. This still says 82 is equal to 55.25 plus F times 0.3. Now on the bottom, what's 0.7 and plus 0.3?
1.
1. Okay, I need to isolate for F. When I divide this all by 1, does it change anything?
No.
No. So I can really just write the top of this fraction, right? 82 is equal to 55.25 plus F times 0.3. Does that make sense from this step to the next? Okay, so isolating F, I got to move 55.25 to the other side. So 82 minus 55.25 is equal to F times 0.3. Take our calculator out. 82 minus 55. 26.75. And then how do we isolate F?
Divide by 0.3.
That's exactly it. This has to come over. We divide by 0.3. So our final grade, or what we needed to get on our final, 26.5 divided by 0.3, 89.1. Okay. So in order for this person to actually get an 82, because their average was so far below it, and this had a low relative weighting, they had to get a very high mark just to pull it up to a grade of 82.